Today we're going to be moving on to topic 2.2, which is postulates, diagrams, and algebraic reasoning. So first thing we're going to do is talk about a few postulates. Some of them might seem pretty familiar to you. We're just giving them kind of like formal names. First thing is dealing with lines perpendicular to planes. So remember, we defined perpendicular during our last topic. Perpendicular lines are when lines intersect to form right angles. So this is dealing with a line that is perpendicular to a plane. So a line is perpendicular to a plane if and only if the line intersects the plane in a point that is perpendicular. Remember, our upside down T means perpendicular to every line in the plane that intersects that point. So again, maybe refresh your memory here. Upside down T means perpendicular. Right? And if you look at this diagram here, we have a plane A. It has lines Q and P on it, and then line T is intersecting that plane. And you can see here there's your right angle box. That means it's intersecting the plane and is perpendicular to it. And what this is basically saying is if T is perpendicular to the plane, then it's also perpendicular to the lines going through that intersection, which would be lines P and Q. So a few postulates to look at that deal with points, lines, and planes. Again, nothing here is new, just kind of phrasing it in terms of a postulate. So a postulate, remember, is a statement that is accepted without proof. We just know that it's a fact. So the first one is called a two-point postulate, and it says through any 2 points, there exists exactly one line. Right, so if I have 2 points, let's say I have points A and B, then I know for sure there is one line that goes through them. Okay? Even if it's not drawn there, a line could hypothetically go through any 2 points. The line point postulate is that just kind of like reversed. This says a line contains at least 2 points. So if you have a line, there will be at least 2 points on it, no matter what. The line intersection postulate says if 2 lines intersect, then their intersection is exactly 1 point. So then their intersection is exactly 1 point. So again, look at this diagram here. You have 2 lines, they're intersecting. That means that their intersection is going to form a point. So I'm calling that point C. The 3-point postulate says through any 3 non-collinear points, there exists exactly 1 plane. So if I have 3 non-collinear points, remember that means my points are not in a straight line, then there's going to be exactly 1 plane that goes through them. So here we have a plane, and let's say there was points A, B, and C. Okay. These points are non-collinear, right? They do not all lie on the same line. Therefore, since these points exist, there is a plane that goes through them. The plane point postulate is just the other way around. A plane contains at least 3 non-collinear points. And then the plane line postulate says if 2 points lie on a plane, so here you have a plane, let's say there's 2 points on it, I'll call that F, and how about this one, E? Then the line containing them also lies in the plane. So remember from up above, if you have 2 points, there is a line that goes through them. So in this situation, you have a plane. This plane has 2 points on it. 2 points are always going to have a line that could go through them. And so what this is saying is if the 2 points are on the plane, then the line is also on the plane. And then last one is the plane intersection postulate. That says if 2 planes intersect, then their intersection is a line. So here we have a picture of a vertical plane intersecting a horizontal plane, and those would intersect at a line right through here. So if those intersect, then they intersect at a line. Okay. So let's look at an example. This is kind of talk about, this example deals with some of these postulates, but looking at it in an example. So like, can we determine these based off the picture? So example 1 says use the diagram to determine whether you can assume the statement. So first thing, it's important to recognize what we're looking at. We have a vertical plane here, a horizontal plane here. They're intersecting along this line. And then we have this line here that's kind of like coming towards us, right? As it goes to Q, it's coming towards us. And then as it approaches M, it's going back behind that other plane. So in number 1, it says planes L and K intersect at line PS. So if you look, we have plane L, we have plane K, and where those 2 planes meet, we have line PS. So this would be yes or true. We have 2 planes, they're intersecting, therefore they will intersect at a line. Points U, M, and O are coplanar. So here's U, here's U, here's M, and then here's O. We have to decide if they are coplanar. Now, with this one at first glance, it might seem like a yes. However, pay attention to where M is. M is on that dotted line, and remember, when something's dotted, it actually means it's behind whatever you're looking at. So M is not actually on the plane, it's actually behind the plane. U and O are both on plane L, but M is behind it somewhere. So this one would be false. We're going to say false, and then we're going to say M is behind plane L. Number 3, angle QOP is a right angle. So here's angle QOP. If you take a look at your diagram here, I see a little right angle box. That right angle box is going to indicate to us that we have a right angle here, right? These lines are perpendicular. So that is a yes for this one, or true. If that right angle box was not there, we would not be able to assume. Line MQ is in plane L. Here's line MQ. It kind of starts towards Q, goes towards O, and then back here, it's going back behind this plane. So remember, when we say a plane is in, our line is in a plane, it is completely contained within it. Plane L is vertical, right? And line MQ is kind of coming at us, right? And then going back. So that would not make sense. It's actually intersecting that plane. It's not actually contained within it. So we're going to say false. And also, if you take a look, line MQ is actually in plane K, because plane K is going to keep coming at us forever, and it's also going to extend back forever. So we're going to say false, and then we're going to say that line MQ is in plane K. Number 5, line PS. Here's line PS. and line MQ intersect at point O. According to our line intersection postulate above, if two lines intersect, they intersect at a point. And if you look here, that point, yes, would be point O. So this is true. And then last one of these, angle SOM. So here's angle SOM and angle POM. That's this one here, are supplementary angles. So remember, supplementary angles are going to need to add to be 180 degrees. And this would absolutely be true because right here, you have opposite rays, ray OP with ray OS, right? And this is actually forming a straight angle here. Angle SOP is a straight angle, which means that the sum of angle SOM and the sum of angle MOP would have to equal 180. So this is absolutely true. Then in the next video, we're going to take a look at our properties of equality.